Okay, so now this is continuing on with Chapter 8 review. Chapter 8-2 talks about using a dial indicator to measure how the alignment is working between two different shafts. And I have to admit, though, I find this chapter useful to read through. I don't agree with the way they do the math all the time. And I provided you a video of a guy doing a dial indicator alignment. And I think it's very, very dependent on the dial indicator setup that you've got. How are you going to do that alignment? So, and also, we're going to kind of gently kind of go around some of these, because the dial indicator is great for many different couplings, but it's not good for all couplings. And it may not even be something feasible to do in a lot of configurations of equipment. But the dial indicator lets me basically clamp a little bar to one of my shafts and then hook a little dial that basically is a sensitive measuring device. And if you set it up to just barely touch a surface and then zero it out, it will, as you move those surfaces around each other, it will tell you how far off alignment they are in mils or thousandths of an inch. So it's very, very accurate in terms of accuracy. You can't beat it from an old school standpoint, except now in a new school, we've got lasers, and lasers are getting cheaper and cheaper. So many shops are going to have laser alignments. This book goes in great detail for the dial indicator method, but gives you very little on laser. So I also provided a video on laser and dial indicator. And the funny part about the dial indicator video is the guy makes a mistake in deciding which direction he needs to adjust his motor as part of the video, which I find very useful and very, very worth understanding. So watch the video, read through the book. Some of the important things you have to remember in this is how you do your measurement. You can measure from a variety of things. You can measure on the rim, or you can measure on the face of your coupling. And so in general, though, I feel like the rim, depending on the coupling, may or may not be accurate, because a lot of times it's the rim that is a cast device. It may not be completely smooth all the way around, whereas the face is machined. But then on some other couplings, the face is a casting and the rim is machined. So you want to measure off of whichever is a machined, consistent, smooth surface when you're doing your dial indication. So watch the video. It'll make a lot more sense than reading this. So I recommend watching the video first and then read through this second. A couple other key points is when you're measuring two couplings that are across from each other, the book says you don't want to connect them as you measure. However, that's not always true. Sometimes these couplings are hooked together by a very soft piece of rubber that allows them to move smoothly and independently of each other. So it's okay to have them connected. And so this isn't 100% true what they say here. However, you absolutely, whether you connect them or not, you want to make sure you turn them together without attaching the flanges. You turn them together whether they're attached or not. And the key term that they use is a witness mark. So if you make a little line on one side and you make a little line on the other, when you make your first measurement, when you turn them, make sure these two marks, these two witness marks, match each other exactly. So that's a very, very important term. And now the book goes through some of the reasons why we don't want to do dial indicator measurements. And one of those is bar sag. If you've got a long rod, that's the distance between the two shafts, and the rod that's holding up the dial indicator is long, it could sag a little bit, right? So as you turn it, that sag changes. So when it goes upside down, it actually goes and droops. in the opposite direction. So that sag, the fact that you don't have, you've got a natural bar there that could sag, changes your reading and gives you an inaccurate reading. So this is one reason why laser is better than dial indicator. It's a common problem in dial indicator. And then they take you through some general procedures to move your mounting on your motor to improve your obviously your alignment. But they also take you some math, and I'm really not seeing the math as important. So you can kind of read through that, get an understanding that there is some math. You might be requested to do it in your job, but I don't see it as important with modern alignment tools. It takes you through a variety of steps here. So read this, interesting, but not critical. I'm also going to skip the reverse dial indicator method, which essentially uses two indicators, and then it's theoretically very, very accurate that way. And there's a lot more math involved in doing that. So we're going to jump to page 181, section 8-4. The feeler gauge method is essentially this old-fashioned method of using a ruler, but instead of just eyeballing it, you're going to use something called a feeler gauge, which are a set of very thin slivers of metal that you slide into the gaps against your ruler. And here they show you an example feeler gauge set, and we've got one of those in our lab kit. And you basically take that feeler gauge and you slide it between the ruler and your coupling. And by sliding it in there and choosing the feeler, the thickness of the metal that's precisely the thickness that will just barely fit into the gap smoothly, you will understand exactly how far out of alignment you are. So when you loosen your motor mounts and shift everything over, you know exactly how much to shift it over. So in this case, you're showing a parallel misalignment. You put a feeler gauge in the gap. Now you know that whatever the thickness of the feeler gauge is, how much you have to move your motor over to do that. And they talk about other fancier tools like a taper gauge. In general, though, this is less common. A lot of guys will eyeball it if they're going to use a ruler like this, or they're going to use a dial gauge, or most commonly now, because they're less expensive, you're going to use a laser alignment tool. So that brings us to chapter 8.5, the laser shaft alignment. Laser alignment tools, and I've given you a video showing how to use a couple different laser alignment tools, two very common, popular laser alignment tools. The methodology you're going to use is going to be very dependent on the kit that you buy. They usually come in two parts. One part gets clamped to the motor, the other part gets clamped to the pump or whatever you're transmitting power to, and you basically just follow the procedures in your laser alignment tool, and it will take you through an alignment. It will often give you a precise measurement for how you need to modify the alignment for those two shafts to be perfectly aligned. And once again, I will mention here, laser alignment kits are very fragile. Therefore, don't drop them, bump them, or whack a piece of metal against your motor or whatever pump you might be aligning when you've got laser alignment tools bolted down to it. Very bad. So that is all I've got for chapter 8. This is a really, really important chapter for this course. You guys should be able to be comfortable to go out into the field and at least be able to read through instructions or listen to the instructions that your supervisor will give you to be able to do an alignment reasonably competently.